Here's assignment 11.3. First part's asking you to identify the major arc and the minor arc. The major arc is going to be the big one, so going around DFE. Remember that F has to be in the center because F is the point it goes through on its way to that last point. Minor arc is going to be the short way from D to E. For the next one, the measure of arc PQ would match the same as the central angle, so it'd be 50. Over here, PRQ would be everything except for those 90 degrees, so it'd be 270. Number 5, it tells you that PR is a diameter, so the diameter is splitting it in half, so 360 divided by 2 parts. That means each part is 180 degrees. Next section is asking you to find the central angle. So the measure of PCQ would be this angle right here, which has to be the same as the 120 degrees. For the next one, this angle has to match to that 65 degrees. And over here, this central angle PCQ has to match to that 150 degrees. They tell you that this is a diameter from A to E. It's asking for arc AD, which would be these two pieces together. So 75 and 40 would be 115 degrees. For BE, that'd be these two sections together, so 75 and 65. So that's 140 degrees. And then for AED, that'd be this side, which is 180, and the 65. So 180 plus 65, we're at 245 degrees. It says to use this formula, which we're going to use the proportion. Remember that all circles are 360 degrees when you're talking about degrees. The 90 is in degrees, so it goes on top of that 360. The X is going to be the piece of the arc we're looking for, this part right here, in centimeters. And then you need to find the circumference by using 2 pi r, and your radius is 6. So this denominator is going to be 37.68. So you're going to get that, multiply it times 90, and divide by 360, and you get 9.42. And that would be in centimeters. Next problem, same thing, set up a proportion. The angle over 360, part you care about, over the circumference, 2 pi times the radius, so that's going to be 31.4. Multiply that 31.4 times 60 and divide by 360, and you find out that your missing measurement, the missing arc, is 5.2 feet. This last one, you're still going to set up a proportion. That angle 120 is going to go over 360. The part you care about is going to go over your circumference. And your circumference is going to be 12.56. So get 12.56, multiply by 120, and divide by 360. And you find out the missing arc is 4.2 meters. It says if you take a clockwise route to the front gate, do you make a minor arc or a major arc? So clockwise goes like a clock this way. If you start here where it says you are here, and you go to the front gate, and you're going clockwise, this is less than halfway across, so this would be the minor arc. It says the measure of one arc you could follow to the front gate is 208 degrees. 208 degrees has to be the bigger arc. It says, what is the measure of the smaller arc? So you get the 360 for a full circle, subtract 208 for the arc on one side, and you're left with 152 degrees as your answer to number 16. It says, name the minor arc and find its measure. So the minor one's the smaller one, so it'd be AB, and the minor arc would be 65 degrees. Your major arc, going the long way around, could be ADB or BDA. Either way, you'd get 360 degrees and subtract away the 65 from the minor arc, and you're left with 295 degrees for your major arc. Next section says determine whether the arc is minor or major or a semicircle for circle C, and it tells you that DF is a diameter. So EF, less than half the circle, this will be minor. Number 4, DEF, that still goes from D to F, which is one side of the diameter to the other side of the diameter. So this would be a semicircle. GDF, that looks like it goes more than halfway across, so that'd be a major arc. From F to G, that doesn't go all the way across, it doesn't go to D, so this would still be less than 180, minor. Then you have EFD, that's definitely more than halfway across, because from D to F would already be a semicircle, it kept going, so that's major. And then from D to G, that's a small arc, less than 180, so that's minor. Next section, it tells you that PS going this way is a diameter, and it says TR is also a diameter. So if this is a diameter from P to S, if this is 80, this has to be what's left over from 180. So that means from this side, it's 100 degrees. Now that we know that, these are vertical angles, you can also say, well, that means that RCS has to be 80 degrees. And then the only piece you're missing is up here. And since you know from T to R is a diameter, these three angles add up to 180. 180 minus 80 and 30, you're left with 70 degrees for PCQ. So now that we have all of these smaller angles, from T to S will be the same as that angle, so 100 degrees. From P to Q will be the same as this angle, 70 degrees. TPQ would be these two added together, so 80 and 70, 150 degrees. Number 12, TQR goes this way around, and it goes from T to R at the end of it. So that's going to be 180 degrees because it's a semicircle. For TRQ, that goes more than 180, so it's going to be 180 plus 30 more. So that's 210. And then SRQ, that'd be 80 and 30 together, so that's 110 degrees. We have almost everything except for this angle GCF, so we're going to want to find that before we start. So 360 minus 60 and 40 and 70 and another 40 and another 60, we're left with 90 degrees. So this right here is a right angle. I'm going to use a little square to say that's 90. The question's asking if the arcs are congruent, so AB is 40 and DE is also 40. So are they congruent? Yes. Number 16, it's asking about BD, which we see is 70. And then GF, which we can see here is 90. That's not the same. So are they congruent? No. Next one, GAB, that's 60 and 40 together, that'd be 100. And then FED, that'd be 60 and 40 together, that's another 100. So that would be yes. And then number 18, AGF, would be 60 and 90. So that's 150. And then GFE, that'd be 90 and 60. That'd be 150. So that's another yes. Down here, you're looking for the length of AB. Whenever it says the length, that's how you know you need to do the proportion. Angle over 360. The part you care about over 2 pi r. So for this problem, it'd be 43.96. And you're going to get that multiplied by 45 and then divide by 360. And you get 5.495, which rounds to 5.5. Next problem, set up your proportion, angle over 360, part you care about over the circumference. So 2 times 3.14 times 4. So 2 times 3.14 times 4 makes 25.12. You're going to get that, multiply it by 110, and then divide by 360. And you get 7.6755555555. So that's going to be 7.7 millimeters. Number 21, another proportion. Angle still goes on top of 360. The part you care about still goes over the circumference. So 2 times 3.14 times 8 for the radius is going to give us 50.24. Multiply that by 75 and divide by 360, and we come out to 10.5. And those are inches. So this is just like the problems that were right above. Your angle is the 27. That still goes over 360. The part you care about ends up being the part of the tire that you care about here. And your circumference is going to go in this bottom part. And it's going to be 2 times 3.14 times 15. 94.2. You get that, multiply it by 27, divided by 360, and you get 7.065. So that'd be 7.1 inches.